Nobody? Complex number, this is chapter 2 stuff.
A fraction.
A fraction, those are rational numbers.
Like 3i plus 4.
Say again.
Like 3i plus 4.
3i plus 4. Colton, can I switch that around and go like this? Okay, Colton says it's something like this, 4 plus 3i. He's right. Complex numbers are your imaginary numbers. You did this back in chapter 2, right? Chapter 2 we did these. 4 plus 3i. Now, what did we do with them? We actually did this. We graphed them, and we graphed them on something that looked like the XY coordinate system, but we didn't call it the x-axis. Instead of calling it the x-axis, we called it the what? The real axis. So guys, the x-axis just turned into the real axis, where the y-axis turns into what? The imaginary axis. Okay? So for us to graph 4 plus 3i, what did we do? How did we graph it? Again? Yeah, it's just basically 4, 3. Okay? 4, 3 is what we did. 4 on the real axis, 3 on the imaginary axis. So that's all we did. Right 4, 1, 2, 3, 4, and then up 1, 2, 3, I. Put your dot here. There it is. We'll call that 4 plus 3i. Any memory of this stuff? Okay, I did it in chapter 2 in your notes. I quizzed you on it. I put it on a test. I put it on the semester test. And you're saying no to me? You don't remember doing this? Really? Okay. Oh, wow. I could have swore you guys would say, oh yeah, I remember doing all this.
I don't think we ever plotted them. I'm like
We never plotted?
95% sure that we never
I'm
plotted them.
100% sure we
You're
never
100% and you're 5% sure.
95.
95. Oh.
I'm 97% sure. 300.
Okay. I'm going back to chapter 2 and I'm going to look this up because it's kind of funny. Everybody kind of said, no, I don't remember this. And I thought, oh, this is something we did.
I mean,
We did imaginary
we went
numbers.
over imaginary numbers. We talked
We
about
never
imaginary
graphed them?
numbers. We never graphed.
All right, I'll look. Okay, you're probably right. Okay. All right, here you go. Let's graph 3 of them. By the way, get used to this. Z1, Z2, Z3, all the Z's that you're seeing, these are all just complex numbers. That's what the Z stands for. You have to graph how many complex numbers? 1, 2, 3. Go for it. While you're doing that, I'm looking this up. I got it. I could have swore we did this. I thought this was all review. No, I don't see it. I think you guys are right. We never did this. Okay, 2 plus 3i. How do you graph it? Yeah, just basically give me the real axis, 1, 2, and up 1, 2, 3, 3i. So it's right here. Z1, right there. Z2, where?
-3,
-3, -1. 1, 2, 3, -1i. Right about here, Z2. Whoops, that looks like ZZ. Z2. And Z3 would be what?
down to up 5.
Up 5? Down 2, up 5? Which way?
Or left to left.
Left 2, up 5 units. Okay, so I'd be somewhere around 5i, wouldn't I? Z3, okay? Any questions on graphing complex numbers? Pretty simple, right? Doesn't it just remind you of graphing x comma y? right? Here's the deal. Would you please think of 2 plus 3i as x plus yi? Would you think of it that way, guys? Because this is the way I'm going to ask you to think the rest of this section. The real number is x. The imaginary coefficient is y. Okay? All right. Now, I know you guys are flipping the page on me, but I got to show you something. Your job today is not quite this easy. You're not just going to graph a complex number. Your job today is to take your complex number z and turn it into polar. Give me polar coordinates. Well, remember polar coordinates, you need to know a couple things. What do you need to know for polar?
Degree.
You need to know the degree and
Radius.
the radius. Remember polar, isn't polar just r comma theta? So r, let's talk about z1. Where's the radius? Well, the radius is from z1 to where? 0, 0, or the origin. There's your radius, r. Theta is what? What is theta? How far the radius did what? Moves around your circle, right? So isn't this going to be theta? Right there. So your job is to turn this complex number, x comma y, into what? Polar, r comma theta. That's what you are doing in this section. Okay, let's move on. I kind of got ahead of myself, sorry. All right. They're going to ask you to find the absolute value of z. The absolute value of z is called the magnitude. Okay, whether you remember this or not, this one I know we did it in section 6.3. The magnitude is the distance of the vector. Okay, that's all the magnitude is. But in your case, it is the absolute value of the complex number. Now, can you tell me what this is? Let's go back to like 7th grade math. What's the absolute value of 5? 5. What's the absolute value of negative 5? Okay, why is the answer 5 both times?
It's the distance from 0.
It is. It is the distance from 0. So the distance from 0 is all the absolute value ever says. How far is 5 from 0? 5. How far is negative 5 from 0? 5, right? Well, you know what this one says? This one says the absolute value of z, and by the way, z is a complex number, is the distance from, not 0, what? The origin. From the origin. Okay. So here's me thinking, oh, okay. If that's all it is, the absolute value is the distance from the origin. What if I make this point up for you? What if I call this point 4 plus 3i? Doesn't that mean I went how far this way? How far did I go? 4. How far did I go this way? 3. So if I went over 4 and up 3, what's the distance from 4 plus 3i to the origin? 5? Why 5? What?
16 plus 9.
Yeah, you said it.
Pythagorean.
The Pythagorean theorem. Exactly. You take leg squared plus leg squared, and you get the distance. And by the way, the distance is the absolute value of z. So you get this, but you have to do what to this? Take the square root, right? So the absolute value of your complex number is the square root of x squared plus y squared. Okay, now where'd they get the x and the y? Well, this is the x value, this is the y value. So guys, when you see a complex number written like this is x, this is y, this is known as what form? This is known as rectangular. So whenever you see a complex number written with a real number followed by an imaginary part, that is rectangular. Your job is to turn this into what? Your job is to turn it into what?
Right triangle.
Polar. And if you guys are going to turn it into polar, you should know from last week, polar is just this. That's all polar is, right? Okay, well that R is the radius. Hey guys, look at that picture. Where's the radius in that picture?
C.
Yeah, well, Colton said it's 5. Well, I didn't finish this. I'm sorry. I should have done this. Z is 5. So Colton says, yeah, this is going to be the radius of my polar form, and he's right. So we can get that. That's so easy to get. All you got to do is take the square root of x squared plus y squared, and you get it. So here's the formula to find the absolute value of z, or the magnitude of z. That's all it is. Square root of x squared plus y squared. Which will help us find this number when it comes to polar. Okay? All right, I'm going to move on, and then you guys will see what's really going on in this next slide. Oh, I'm sorry, I went too fast. We have to practice. Let's get the absolute value of z. So here is an example of rectangular form. Let's take rectangular form and plot it on the complex coordinate plane, and then find the absolute value of z. I don't think plotting it was very difficult. Getting the magnitude or the absolute value of z. You have to remember that in this form, your x value is -3, your y value is 2. So hopefully you did something like this, right? And if you look at this triangle that it forms, there's the distance right there. What'd you guys get?
Square root of 13.
Square root of 13, yep. Okay, so 9 plus 4, 13, square root. So I agree. The absolute value of z is square root of 13. But another name for this, when it comes to polar, in polar form, what did you just find?
The radius.
You just found the radius. Okay, so really you would know this is the square root of 13, and then of course you got to figure this out. You have to figure that out. And you and I have already done this in 10.7, so this won't be hard for you. Okay? So this is coming. We're not going to get into it quite yet. All right, you ready? Next slide. Okay, here we go. This is what you have to know how to do, because if you can't move past this slide, we're in trouble. All right. We are trying to get everything in polar form for complex numbers. I need polar, I need r theta, I don't want x's and y's. Okay? It says here, since x equals r times cosine of theta and y equals r times sine of theta, since this is true from chapter 10.7, and by the way, do you remember how we proved this? How did we prove this? Did I just give it to you? You guys, do you remember how I got that? Didn't I draw a triangle out here, or something like this? A right triangle. Called this my x, this my y, this my r. This is theta. And then we said, how do we know x is equal to this? Well, we did something like this. Cosine of theta equals, what does cosine of theta equal? X over r. Then we cross multiplied and said that x equals what?
R cosine.
R cosine. And then I'm not going to show you the other one, but the other one would be y equals r sine. This is what we did in 10.7. So now, here's what they're doing in this lesson. They are going to give you z. What is z? What does z stand for?
Complex number.
Okay, they're going to give you a complex number. Good. That's what z is. Here's a complex number. And what form did they write it in?
Rectangular.
Rectangular. And all rectangular means to you is 5 plus 2i, 7 minus 1i. That's all it is. And you're going to convert this to what? Polar. How are you going to do this? Watch what they did. Ready? See that x? What is x? R cosine of theta. They put it right here. X is r cosine of theta. Y is r sine of theta. And then they rewrote the x and the y with this in it. Then they factored out what? They factored out an r. Right there. When they factor out an r, all that's left inside is cosine of theta plus sine of theta times I. And by the way, I always put the I behind sine. Sine of theta times I. Just because it's yi or bi, I like the I in the back. Okay? So, you guys, this is what form? What form do we call that? Polar form. This is rectangular form. Your job will be go from here to there. Go from here to there. Alright? Alright. Oh, sorry, I forgot to say something, and that is this. You see these angles here? These angles that you're going to put in here, they need to be between what? 0 and 2 pi. Because if you go past 2 pi, our answers start to repeat. They're the same answers. Okay? This is called, theta is called the argument of z. It's the argument, and all that means is, you guys, you can't just assume you know the angle. You have to remember, sometimes the angle's in the first quadrant, second, third, fourth quadrant. It's an argument. We have to decide which quadrant it's in. All right, here's your first problem. Write the complex number 1 plus I in what form? Polar. You got to get it out of rectangular. That's what it's in, by the way. This is rectangular, and get it into polar. Here we go. Okay. First of all, it is rectangular. Rectangular is going to be x plus yi. Is that what it looks like? Yeah, 1 plus I is what you have. Okay, let's move it over and get it in what form? What form? Polar. Okay, if we get it in polar, then we better know what polar is. Polar, if you look up above on your slide, is r times, what does it say? Cosine of theta plus sine of theta times I. That's all it is. So we need this to look like this, and then we can call ourselves done. All right. Any idea how to get r? Yeah, 1 squared plus 1 squared, take the square root of it. Okay, so in other words, Colton kind of did this little number in his head. He said 1 plus 1i is over 1 up 1i. So he says it's right there. Okay, what's the radius of this point? From there to there. It's actually the absolute value of your complex number. So it is square root of 1 squared plus 1 squared is square root of 2. So the radius is the square root of 2. Everybody agree? Here's what you have to know now. You need to know theta. Theta. Well, theta is how much I rotated. Look, right here. How much did I rotate to get to there? And we did this in chapter 10:7. How did we do it? Guys, if you make your triangle, it's over 1, it's up 1. Didn't we use something here? Wasn't there a formula we used for to get to get theta? Yeah, didn't we do tangent? Tangent of my angle, right here, equals y over x, 1 over 1. And guys, those numbers are so easy. When it's 1 over 1, what angle is it? Yeah, basically this is what you're doing. Inverse tangent of 1 over 1. And hopefully you remember that is 45 degrees, or better yet, pi over 4. Right? Alright, that helps me, because now I know to get it into polar form, I just need the radius, and I need the angle I rotated it at, and it was what? Pi over 4, cosine of pi over 4, plus sine of pi over 4, times I. Okay. You know what I just did? I just took rectangular form right here. This is rectangular form, and then I did this. I turned it into polar. I'm done. That's all it was. Can you get the radius out of this? Yes, I can, by using the Pythagorean theorem. Can I get the angle? Well, yeah, I had to use tangent of theta to get the angle. Good? How do you know you're right? How do you know you're right on the test? How could you check this to be sure you're right? You're telling me this is this. Are you positive? You're going to say, yeah, I'm positive because you did it and I trust you. Not good enough. You guys shouldn't be saying that. How do you know that is really this? Come on, guys, look. I'm telling you 1 plus I is really that. Well, for you to be sure that's right, shouldn't you have to take that problem and do something to it?
Solve it, distribute.
Yeah, I distribute. Yeah. Take this times this and see if you get 1. Do you? Hey, do you know the square, do you know cosine of pi over 4? Here's pi over 4, 45. Here's a 1 square root of 2. What's cosine of 45?
1 over square root of 2.
But that rationalizes to what?
Square root of 2.
Square root of 2 over 2 plus, what's sine of this?
Same thing.
Same thing, times I. Now, what is this? Square root of 2 times square root of 2 divided by 2? Isn't that 1? What is this?
1i.
1i. Is that what you started with? Now you know it's right. See, when I'm doing a test, I don't want to just say, that's the answer. I trust that that's the answer. Well, I don't trust anything. I double check things all the time. That times that and that times that is that, which is what I said it was in the first place. Okay. I know that's a lot of talk on the same problem, but just have to get that through you. Okay. What are you going to do with these complex numbers that are in polar form? You're going to do 3 things today. What operations are you going to do? You are going to multiply. You are going to, can you see yours better than mine? Are yours better? Yeah? I can hardly see these. And then this one is you're going to take a complex number and raise it to a power. So we're going to do 3 things with our complex numbers. And by the way, all your complex numbers are in what form? What form is this? Polar. You guys, I'm giving you your complex numbers in polar form. So when they're in polar form, there are 3 formulas. Here they come. Formula number 1, if you multiply 2 complex numbers in polar form, you take the radius and do what to them? Just multiply. Then you take it times cosine of the 2 angles added, plus sine of the 2 angles added, times I. So multiply the radius, add the angles. When you divide the two radii, subtract the angles. Now, this one, when you raise it to a power, you take the radius and you raise it to the same power of the complex number. And then you take it times cosine of your angle for that complex number times whatever power you raised it to. If I raise it to the fourth power, that will be 4 theta. This will be 4 theta again if it's to the fourth power. See these formulas? You're going to have to memorize them all. Can you do that?
You have to memorize them.
Do you want to do that?
A formula sheet?
No, I'm saying you have to memorize them all. Is that okay?
No.
No? You don't want to?
Yeah.
All right. You don't have to. I was just trying to get you to see if you were awake. You do not have to memorize those formulas. Here they are. All right. I got all the formulas for your test on Friday. They're right here. Now, what I want you to do is go to the next slide and actually do this problem. Take W times Z, and up here I've got W and Z, and W and Z are your complex numbers in polar form. Do not lose this. You can use this on the test. This does not take very long if you just follow the formula. W times Z. There's your formula. I just copied it down just so you can see it. When you take two polar complex numbers, all you got to do to multiply is multiply the two radii. You get what? 12. You know what? I'm not going to write 12. I'm going to write 3 times 4 just so you can see it. Okay, cosine of your two angles added together. Your two angles are
30 plus 45.
30 and 40, yeah, 30 and 45, that's easy. Plus sine of 30 and 45 times I. So let's simplify the answer. You do get a 12, cosine of what? 75 degrees, right? Plus sine of 75. I. You're done. That's what I said, it's not hard. Did you get rid of your, oh wait a minute, I was thinking I was converting. I'm not converting. I'm just multiplying two polar complex numbers. When you multiply, it's R times R, 12. Add the angle, 75. Add the angle, 75. You're done. Okay. Is there anybody out there that wants to do this? Is anybody tempted to do that? Anybody? Nobody? Nobody's tempted? If you did it, what are you doing? Okay, somebody do this. 12 times cosine 75. Do that, please. Just do it. I need you to tell me what you just did when you do this. What is 12 times cosine 75? 3.1 plus 12 times sine of 75. That's like 11. 11.6. Okay. I. Okay, look at that answer. Now look at this answer. Look at this answer. Now look at that one. What's different?
No.
This one's rectangular. This one's polar. Rectangular, polar. What do they want you to do? They never said. They just said multiply the two polars. They never said change it back to rectangular. If they said it, I'd do it. But they didn't say it. So I left it like this. Okay?
Wait, so you have to say that.
No, I'm saying you don't have to do this. I'm saying people get tempted to do this, and they don't have to do this. Okay? This is rectangular. If the book ever says, Hannah, go back to rectangular, then go do what I just did. Okay? Okay, do the division. The division's next. It's W divided by Z. Uh-oh, I'm running out of room, guys. I can't. When you subtract the angles, which one's which here? What, the angle from which one?
Yes.
Isn't this going to be W, whatever on top, minus Z? W minus Z? Isn't that the way it's written in the formula? So this would be what here? The 2 radius when you divide are what? 3/4 times cosine of 30 minus 45 is negative 15 degrees plus sine of. Would that be the same? I. Good? That's all it is. Again, I could do the distribution, but if I did that, I'd be going back to rectangular form, and I don't think they want that. They never said they wanted that, so don't do it. Okay. Last but not least, take what are we doing here? Take what?
W.
W and do what to it? Cube it. Okay, go cube W. Pretty much this is the formula, right? Your complex number W raised to the n power would be this. So you're going to take W and you're going to cube it, which means take your radius and what? Radius is 3, cube it. Cosine of? What's your angle? 30 degrees times? 3. Yeah, whatever n is, 3. Plus sine of? 3 times 30 again. I. You end up with 27 times what?
Cosine 90 plus sine 95.
Cosine 90 plus sine of 90 I. Right? Okay. Hang on one second. Thank you. Am I done? That is in polar form, isn't it? Can I ask you this? What if, just what if the book says, go back to rectangular? Give me x plus y I or 2 plus 3i. What do you do now? Yeah, you distribute it through and through. And the reason I wanted you to do this one is because 90 is actually a really simple, it's a simple point on our circle. It's just 0, 1. You guys remember doing these? What is cosine of 90? Cosine is x over r, guys.
0.
0 over 1. You're right, it's 0. What's sine of 90?
1.
Y over r, it's 1 over, yeah, it's 1 over 1. So it's 1i. What's the answer? Isn't that the answer in rectangular form? Oh, don't miss it for you. And then, you got your 4 minutes each, you got your works, your calendar, you're good. You just didn't get to see your quiz. Can I give this back tomorrow?
Sure. Did I do a counting or did
I don't remember, it's been 3 days. If you guys want to stop by and look at these quizzes, that's fine. Yeah.
Like better school.
Yes, you need to come in, I need to sit down with you for at least 20 minutes, okay, or so. You want to see the quiz?
I don't know if that's.
Corey, how much to look at? You did get, you got 2 wrong, but then you picked up 2 more. We'll look at these. That's better. Right there.
Oh my god.
You did very good. Very good. Yeah. Why not? Every 4, right?
Yeah, you get to 92, and then you go to 96.
80, 84, 92, then 96, so that should be a 6. Yeah, let me look at 96, see if that's what I wanted you to do. Are you looking at day 2?
I was just writing it out.
Hmm.
Can I look at my
Mm-hmm. You can.
Did I do good? I don't feel like I did very good.
I don't remember, I just, these grades don't even look familiar. Okay. 18 by out of 20. I think that's 92 and a half.
Okay.
There it is.
Mhm.
Something like that? Okay, so this is period 6. Okay, I'm gonna shut this off.